Okay, so I think it's time here to start. So first of all, thank you so much for attending my session here. My name is Håkan Silfvernagel. I work as an AI evangelist for Supersteria, and I'm also a Microsoft AI MVP. And today I'm going to be talking about how can we enhance our AI services using an open source framework called Semantic Kernel. But before we dive into all of that, I need to give you some more context and some history. So I would like all of us to close your eyes and think back maybe 3 to 4 months. Well, actually, you can have your eyes open here. But around Christmas, so I'm from Sweden, and around Christmas time, we have a tradition in Sweden that we write something we call Christmas rhyme. So the week before Christmas, the whole family is gathering with grandpa, grandma, and aunt, and uncle, and so on. And then for each Christmas gift, we try to write a Christmas rhyme that will somehow describe what is in this Christmas packet. And we also make a handwritten illustration. And I was thinking that maybe, because I'm not that good of a writer, not very good with rhymes, so I was thinking maybe I can use AI to help me with all of this. So basically what I did was I created an application so that I can create a Christmas rhyme, and then based on that Christmas rhyme, based on the item, I can also create an image prompt, and based on that image prompt, I can send that to DALL-E and then get back an illustration of this gift. So I think it's actually easiest if I show you how this application will look like. So in this application, and I also want to give a shout out here to Matthijs van der Waal, who I met at Meetup or a conference in December, and I could proudly steal his code, which enabled me to make this application very, very fast. But basically what is happening here is we can select a gift item here that we want to give away. So let's say here that we want to give away a book. Then we select book, and then we can create a rhyme here. So the way that this rhyme is produced, it has a particular way of rhyming, and we're going to see how can we make our LLM understand this rhyme so that we get it into the appropriate rhyme. So I'm going to I will read this up here. So here it says here, so the book, the Christmas gift here is a book, and then it says in pages filled with tales so bright, a world awaits both day and night. So cozy up, take a look and see, this gift of book is just for thee. So I think that's quite a nice rhyme. It's certainly much better than what I would have been able to come up with myself. And then we can also get an image or an illustration. So sort of behind the curtains here, what is happening is that we send this gift item to Azure OpenAI, and then we ask Azure OpenAI to come up with an image prompt, and then we send this image prompt over to DALL-E 3, and then DALL-E 3 will generate an image where we can set some specific criteria here that we would like this image to be very, very Christmassy. So it should have bright red colors, it should have Santa Claus, and it should also have this gift here in the illustration. And we can see here that this picture certainly look very Christmassy. So sort of in the reminder here of my session, I'm going to be describing here how did we develop this application. So we're going to start out here in Visual Studio Code, and I'm going to show you how can we make use of another tool called Prompty in order to do rapid prototyping, so that we can rapidly gain feedback and understand if I make changes in my prompt over here, how will this image look like, or how will this Christmas rhyme look like. And then when we're sort of satisfied with how that all looks like, then I'm going to show you how can we actually use this result that we got from our prototyping into more real-world-like project in Visual Studio. But first, I'm going to tell you some more information here about Semantic Kernel. So let me go back here to my presentation. But first of all, I would like to thank the Platinum sponsor, who also happens to be my employer here, which is Supersteria, for making this conference possible here. So thank you so much. And here's some more information about me. So right now I'm working as an AI evangelist for Soprasteria. And I've also been a Microsoft AI MVP for the last 5 years. And if you want to get connect with me, I'm going to give you a QR code for connecting on LinkedIn. And also all of these code examples that I'm going to be showing you, I will also give you QR codes so that you can connect to the GitHub repo and try it out yourself. And I'm from Oslo, Norway, and I'm quite active in the local user community. So I'm part of organizing the Norwegian.net user group and also the Oslo AI meetup. And I'm also part of 2 virtual meetups. The first one I co-founded with 2 other MVPs during the Corona. That's AI42. So that's an online AI school on YouTube, which is totally for free. So if any one of you would like to dig into AI and machine learning, I recommend to have a look at that. And the other one is it's a bi-weekly user group called Azure User Group Sweden that I'm running together with Jonah Anderson, who is an Azure MEP in Sweden. So now on the agenda here for today, first I'm going to be talking a little bit more about AI assistants and AI agents, so we can understand a little bit about the differences. Then I'm going to be describing Semantic Kernel and also another tool that is called Prompty. And the majority of this session will be spent in Visual Studio Code and in Visual Studio with many different types of demos. And then I have a short summary with some links if you want to learn more about this, or if you want to download the code and try it out yourself. So if we say here that, like the past 2 years, or 2023 and 2024, there was a lot of talk about AI assistants, about ChatGPT and different types of copilots. And what these have in common is they are conversational AI, so it means that we communicate with them through prompts. So we as a user write a prompt, and then we will get back some sort of a recommendation, which is based on the information and the data that the AI has access to. But then AI agents, on the other hand, they don't require prompts. So instead, what is happening is that you can give an AI agent a goal, and then if you give it access to some functions, it can figure out by itself which functions should I call and in which order. So it can plan and develop its own workflow by itself. And that's a very strength of AI agents, that we don't need to explicitly program them. We can just give them a goal, and then the AI agent will figure out by itself, how should I reach this goal that has been given to me. And one of the tools that we can use, or one of the frameworks that we can use for creating this type of agents, is called Semantic Kernel. So Semantic Kernel is an open source framework, and we can say that Semantic Kernel is like a middleware that sits between your application code and the language models. So it's important here to understand that the Semantic Kernel in itself is not an AI model or something like that, but it's more like a middleware that helps you with have a much better organization here of the workflow of your different types of models here. And we can write a semantic kernel in either C#, Python, or Java. And the way that it works here is that we can create plugins. So I'm going to show you how these plugins looks like. So either we can create plugins which is in code, but we can also develop plugins using JSON and the text file here. And we also have integrations. So for example, maybe I want to do a weather lookup, or maybe I want to do like an internet search. Then I can do an external connection in order to get this kind of information. And right as of now here, we can see that there are different types of capabilities here, depending on which type of language you're using. So right now we can see here that C# gives us most capabilities. So in this Christmas rhyme demo application that I showed you, then we need to have this functionality so that we can have text to image. And right now that's only supported through C#, so that's why we are using C# for that. But we can envision that in the future, probably Python and Java will be on par with the other languages. And another tool that I would like to tell you about is called Prompty. So Prompty is a way that you can have a much better structure on your prompts. And it's also a great way here to do rapid prototyping. So Prompty is an extension to Visual Studio Code. So if you install that as an extension, then you will get the template here. So this is the template from Prompty. So basically, it gives you a name and also a description of what does this Prompty file does, and also some configuration parameters for your language model. And then you can also give it some context and some examples of what should this Prompty file, what type of tasks should this perform here. And you can also give it a system prompt and some more information. And what is very neat with this prompt is that by using this play button up in the top right corner here, you can very easily run this and get feedback almost immediately. And then it's very easy to change this. This is just a text file. So it's very easy to do changes and try out different types of combination and different types of prompts and see how it looks like. And the Prompty is supported both by Semantic Kernel and LangChain and also prompt flow. So if you're not such a big fan here of writing code, you can also try out prompt flow. It will give you like a playground here where you can, which is much more graphic. So here you can just choose by drop-down menus and write things. You don't need to code it, but you can use this playground instead. And the way that we use Prompty then in our application code is similar to this. So here in line 9 to 11 here, we are collecting the configuration information for our Azure OpenAI instance. We need to have the API key and the endpoint, and also we need to have a language model deployed here. So we need to have the deployment name here of our language model. And then after that we can create a semantic kernel object, and then we need to add what kind of capabilities do we want to have here. So here we say that we want to have the chat completion capability, and we just plug in the deployment name, endpoint, and the API key. Then we can provide it with some arguments, and then on line 29 we actually create a function from this Prompty file that I showed you. We can create a function that we then can invoke on line 31 and get the result back. So then basically we get the result back from this prompt that we had written in our Prompty file. So so I'm going to show you how that is done in a very short while here. But I think one thing which is important here to recognize is that neither Prompty or Semantic Kernel, they are not AI models by themselves. So the first thing that we need to do is to go to Azure portal, and then we need to deploy an Azure OpenAI instance, and then we need to deploy a language model. So let me go over here to the Azure portal, and let me do like this. So now we're in the Azure portal, and then we can create a new resource here, and then we can search here for Azure OpenAI, and we only want to have the Azure services, and then we create. And then here, just as you deploy any other type of resource in Azure, you're just defining which resource group do you want to have in which region, and give it a name and also a pricing tier. So if you do all of this, then you will have an Azure OpenAI instance deployed here. So I've already deployed one of these instances, which is this one. And then we can have a look at this page. So now this is obfuscated, but here we can get this API key that I was talking about, and also the endpoint for our Azure OpenAI instance. And if we go back here, Then we can go also to the Azure AI Foundry portal. And from this Azure AI Foundry portal, then amongst many other things here, we can deploy some language models that we're going to be using here for our examples. So if we go down here to deployments, then we can see that I've deployed a number of different models here. So what we are going to be using is this one, the GPT-4o mini model. And we're also going to be using this, the first one here, the DALL-E 3 model. So the first one, GPT-4o mini model, that's the one that we're going to be using in order to get this Christmas rhyme, and also in order for us to get this image prompt. And then we're going to be sending this image prompt that we get, we will send that over to this model, the DALL-E 3 model, in order to get this Christmas illustration. So now when that is out of the way here, then we can go over to Visual Studio. So one moment here. So now I'm going to show you a number here of examples here on how we can use Semantic Kernel. So it's important here again is to realize that the first thing that we did was we deployed this Azure OpenAI instance, and then after that we deployed some language model. And now and the Semantic Kernel is just like a middleware that sits between your application code and these language AI models. So in this first example, we're just going to be using Semantic Kernel. We'll just be forwarding our questions here as a prompt over to our AI model here. So what we do is we create here a Semantic Kernel object, and we specify that we want to have the chat completion, and we use the deployment name, the endpoint, and the API key. Then we build our kernel, and then we can invoke this kernel with a prompt here. So here we ask what color is the sky, and then we just write it out on the console. So if we run this thing over here, yeah, so basically we asked there about the color of the sky, and then the Semantic Kernel just forwarded this prompt over to our language model, and then it retrieves the answer back here to us. So here we get the paragraph that the color of the sky can vary depending on several factors, and so on and so forth. So that's a very easy example here. But another thing that we can do that I would like to show you is, one moment here. So I'm going to show you how can we provide Semantic Kernel here with some arguments here. So here we are creating some kernel arguments. We specify that the topic that we want to talk about is the sea, and then we invoke a prompt here, what color is the, and then there's a special syntax for invoking this kernel argument here. So let us run this one too. So here we can see that the topic here was the sea. So now we get the color of the sea can vary widely depending on several factors, and a paragraph about it. So then in our next example, we can also show here, that we can also provide some runtime settings here to our models. So here again, we provide it with an argument, which is the topic here for our discussion, and then we provide it with some OpenAI execution settings. So we set what is the max number of tokens and what is the temperature, for example. So if we run this. And then we can see here that we got a very long paragraph here about the topic that we decided upon. So this is, a simple example here of showing you how can we use Semantic Kernel like a middleware middle layer or middleware between our application code here and the language model. But then the real strength here of using Semantic Kernel comes in the plugin concept. So I'm going to show you here how can we create the plugin and how can we make Semantic Kernel use that plugin to perform some functionality. So let me set this as a startup project. So here in this example here, we started out exactly as we did with the previous examples here, that we create a Semantic Kernel object using the deployment name, the endpoint, and the API key. And then we build that kernel object, and we say that we want to have the chat completion service. And then we can add a plugin here to our Semantic Kernel by just specifying kernel plugins, and then add from a C# type here that we have in our project called light plugin. So if we go over here to the folder structure, we can see that we have a folder called plugins, and under that plugins folder we have lights, and then we have a lights plugin. So if we have a look here at the lights plugin, then we can see that basically it's just a regular C# class here where we have a model of a light. So we have a name of the light, and we also have some Boolean property if the light is on or if it's off, and so on. And then here comes the interesting part here, because we have decorated up some functions here with a decorator called kernel function. So what that means is that when Semantic Kernel sees that, then it understands that this function I can make use of. And what it looks like, what it looks for is the description. So based on this description, it can understand what function should I call and in which order should I call that. So that's it's the kernel function together with this description that helps the Semantic Kernel to be able to do its planning and to create its own workflow here. So here we are describing here that this function will get the list of lights and the current state, and it returns an array here of lights. And then we also have get state, which gets the state of an individual light and returns that state. And then we have also a function here called change state, which changes the state of the light. And then if we go over here to our program, we can see here how we can test this thing out. So we added the plugins here to our Semantic Kernel object. And then after that, we need to set up here that we enable planning here for our Semantic Kernel object. And then basically we're just starting a chat here where we say, please turn on the table lamp. And then we will write back here, what do we get back here from our agent. So if we run this example, then what we said here in the code here, what was that we wanted Semantic Kernel to turn on the table lamp, and then we get back here from the agent that the table lamp has been turned on. And this might sound like a very trivial example, but I think that what it shows here is that we as application developers, we didn't really need to write any code here in order for this turning on the lamp functionality. Just given that we have this plugin, the lights plugin, and we can have other plugins too, then we can just give Semantic Kernel a goal. So the goal here was to turn on the table lamp, and then the Semantic Kernel can figure out by itself for which function should I call in order to turn on the table lamp. But then in our next example, we can also see here how can Semantic Kernel do planning in a little bit more complex setting here. So now we have the same light plugin as we had from before, and then in our code here we create our kernel object and we build it and we want to have the chat completion service, and then we load this lights plugin exactly as we did before, and we set that we want to have this planning enabled. And then we start just the loop here so that we can give commands into the Semantic Kernel, and we will get the result back here from our agent. So if we start this thing here, then we can write something like get the states of all lamps. So now it figured out by itself here which functions do you need to call in order to get the states here of all the different lamps that are available here. And then we can say, for example, switch the state of the table lamp. So then it reports back here that the table lamp has been switched on. But we can also write something like this, switch the states of all lights. So now we said switch the states here of all lights. So then it switched the states. And here it needed to do some planning here, because first it needed to retrieve what is the current state, and then it needed to switch the state for all individual lights, and then finally it needed to report back what is the current state of the lights. So even though these examples might sound or seem a little bit trivial, this I think gives a good understanding here of the strength here of semantic kernel, and the way that we can give it a goal, and the way that semantic kernel itself can do both planning and create a workflow by itself. Also an example here of another thing that can be interesting, which is memory. Oh, sorry. So here in this example, we're going to show here how can we use in a runtime memory here. And what we do here is we create the semantic kernel as we did before, and then we provide a text embedding service, and then we create a semantic text memory. And this one is a runtime memory, but there is a special interface that you can implement. And if you implement that interface, then you can store your memory in SQL Server or Postgres or anything. So what we do here is we save some information to our runtime memory. So we save information about what is my name, or where do I work, where have I lived, and which countries have I visited, and so on. And then after that, we provided the semantic kernel here with some questions, and then we just write out the answer for these questions here. So if we run this, we can have a look at what it looks like. So here in this example here, what semantic kernel is giving us back is both a probability of that answer is correct. So here it said that it was 83% probability that the name is Andrea, for example, and so on. So this is a simple example also to show you how can you work with memories in your application. So now, when we know a little bit more here about semantic kernel and how can we communicate with semantic kernel here, then we can go back here to this Christmas rhyme application. So I'm going to show you how we started out there in VS Code to do some rapid prototyping. So let me go over to VS Code. So here is VS Code, and here we've installed Prompty as an extension here to VS Code. And what we get here with Prompty is we get a template that is already filled out for us, and then we can just edit that template so that it fulfills our needs here. So basically, we just need to give it a name and a description. So here the description is that this is a prompt that uses a gift item as an input, and it will create the Christmas rhyme back as an output. And then we specify that we're using Azure OpenAI, and we need to provide with some configuration parameters like the endpoint and the deployment name here. And we can also provide some parameters like the maximum number of tokens and the temperature. And we can provide what kind of format do we want the response to have. So here we want to have a JSON object back as a response format. And then we can give it some context here. So then we will give it some examples here so that it can understand in which format do we want to have this Christmas rhyme. So then we say here that you should provide a Christmas rhyme for a particular gift, and the rhymes should be in the following format. And then we give a number of formats, give a number of examples here of how these Christmas rhymes are structured here. And we also give a system prompt here that you are an AI assistant who helps people with rhymes for their Christmas gifts. And as the assistant, you will write a rhyme based on the gift item and answer in a personable manner, and even add some personal flair with appropriate emojis. Respond using the JSON format by including the original gift and the rhyme. So then we can try and run this directly here from VS Code by just pushing this button here. So then we can see that it's connecting, it's calling our Azure OpenAI instance, and then the gift item was here a cozy blanket, and then it says the Christmas rhyme is, as winter winds begin to blow, here's a gift to keep you aglow. Snuggle up and feel the warmth, Håkan's love will be your charm. So that's quite a nice rhyme. So but the main idea here is then that it's very easy for us to change this text file and to run it over again and to do some rapid prototyping until we are happy here with the result. So let's say that we are happy now with the way that this Christmas rhyme is composed. Then the second thing that we wanted to do was to have this illustration. So the way that we will create the illustration is to make use of our language model in order to get an image prompt, which should be very Christmassy. And then we send this image prompt over to DALL-E 3 in order to generate an image that we then can use in our application. So in a very similar manner as before here, we give it a name, create image prompt, and we say here that this is a prompt that uses a gift item as an input and create an image prompt back as an output. And again, we give it configuration parameter with the endpoint and the deployment name and some runtime parameters. And then we give it the context here that you should take a gift as an input and turn that into an image prompt for DALL-E 3. And then we say here that, here we can do the specification here of how do we want this image to look like. So then we say here that the image should always be Christmas themed with a lot of red colors and winter details in it. There should be either Santa Claus, reindeers, or the Santa Claus dwarfs in the image. And the system prompt is you are an AI assistant that helps people with illustration for the Christmas gift. As the assistant, you will write the prompt that DALL-E 3 will use to generate the image. Respond using the JSON format by including the original gift and the image prompt. So then we can try this out again here from VS Code. And remember that now we will only get the prompt here, we will not get the image. So here we get that the gift was a book, and then we get an image prompt here that is a beautifully illustrated Christmas scene featuring a cozy reading nook with a large colorful book, and so on. So let's say that now we're still here in VS Code and we're still prototyping. So then we would like to see how would all of this looks like if we combine our rhyme prompty with our image prompty. So then we can just create a small program in order to try that out. So here basically we create first a semantic kernel that will handle this rhyme, and we give it some arguments here, and then here on line 31 here we create a function from our prompty file, and then we invoke our prompty file here on line 35. So here we get this Christmas rhyme on that line here. And then a little bit further down here, we create another kernel object here, and then we create a function from this image prompty file on line 59, and then on line 63 we invoke it. And then finally, what we need to do, because now we have the image prompt as a prompt, which is a text, and then we can use one of these built-in functions that I was showing you here on the PowerPoint slide that was supported in C#. So this capability or function is called text-to-image service. So that's just a built-in function, so we can just say for a kernel object, get the required service, the text-to-image service, and then we can just invoke that service, generate an image based on this image prompt that we were producing. So if we run this one So now we can see here that the first prompt was, so the gift was a book, and then it says, "For you, dear dad, I found a treasure, a book of tales beyond all measure. From gripping plots to wisdom's nook, dive in and enjoy this lovely book." And if we continue here, then we also get here an image prompt, a cozy Christmas theme featuring a beautiful wrap book in the foreground, and so on. And then if we continue again here, so this can take a little bit of time here, because then now it will send this image prompt over to Dolly 3, and then Dolly 3 will generate the image and then send a URL to us. And then we can paste this URL in the browser and have a look if that image looks like something that we are satisfied with. So now we got the URL back, and then we can just take this URL, and then let's find the browser here. Somehow this reminds me of the 1990s. Sorry about that, but we can anyway, we can see here that this image looks like it's very Christmassy, and we can see Santa Claus and his this book item that we were specifying here. Yes. Yeah, so then let's say here that we are happy here with our prototyping, and then the final step here is how can we then create, if we want to use this in a little bit more complex application here. So then let me switch over here to let me switch over to this one. Yeah, so here basically we have an application here, which is a Blazor project for creating this Christmas rhyme application. And then we divided it into a number of different projects, and one of the projects is this one, the AI project. And the AI project deals with everything that has to do here with the communication with Azure OpenAI instance, and also this prompt files. So basically what we have done here is that we've just copied our prompts here over from Visual Studio Code into a prompt folder. And here is the same prompt as we used in VS Code, the create image prompt, and also create rhyme prompt. And then similar here to what we had here in VS Code, we also create our kernel, semantic kernel object, and we do some dependency injection here. So for example, here we have a rhyme service. And in this rhyme service here, we are taking the gift name that we had, and then we invoke here the function based here on the create rhyme prompt file that we had here before, and we get the result back. And then in a similar manner here, we also create this Christmas image. So we invoke this function, the prompt function, and we get the image prompt back, and then we're using this text to image service that we saw that we got provided here for free out of the box, in the same way as we did here in VS Code. So the last thing that I would like just to show you is if we run this function here again, or if we run this program here again. And then we create here a tie. Yeah, so it's not so important here exactly what this rhyme is. I just wanted to do some actions here. we can wait here until the image has been displayed there. Because the only thing that I wanted to show you is that we're also using .NET Aspire here in this Blazor application. And then by doing that, we get this portal here, where we can both get some logs. And what can be of interest here is, for example, we can see here how many tokens have we used here. So for example, here, the prompt tokens was 400, and then we have completion tokens, 83, and we get the number of total tokens. And that can be quite handy for us when we are doing debugging and developing. And this, in a similar vein here, we can also get some details here from the endpoint and other details for our application, which can also be useful for debugging or for logging. So let me switch over here to the presentation. So so basically, I hope that you found this presentation interesting. So my goal here was to get you interested both in semantic kernel and in Prompty, and also show you that it doesn't require a lot of code, and you can do a lot of prototyping fast in VS Code. And that you can use whatever you found out in VS Code, you can use it very rapidly over in Visual Studio. So if you want to know more about this and want to try out this example, plus many, many more examples, you can go to the official GitHub repo for Semantic Kernel. And there also is a Microsoft Learn segment also on Semantic Kernel, so you can scan this QR code if you want to know more about that. And I would be very grateful here if you want to give some review here on my session. So then you can just scan this QR code, and then you can add your reviews in that form. And if you want to follow me, feel free here to connect here on LinkedIn. Just scan this code here. And with that said, I would like to thank all of you for coming. And I wish you a happy continued Future Tech conference. Thank you so much.